Everyone, John here, and this is my reaction video for experiment 5 on performance specification of our second order control system. In this experiment, I used MATLAB to analyze the step response of second order system by varying parameters such as damping factor, damping frequency, and adding zeros and poles. The output shown here are plot step response for different conditions. So I started defining the transfer function in standard or second order form and computed key parameters like natural frequency, damping ratio, and damp frequency. Then I ran simulations where I varied the damping factor to observe how oscillations and overshoot charge, and I changed the damp frequency to see how fast the system responds. And I added zeros to the system, which made the response more aggressive and increased overshoot. And lastly, I added poles at different locations like -100 and -1 to study their effect on the system. From the plots, I observed that how each parameter affects rise time, peak time, and settling time, and overshoot. One challenge I encountered was understanding how the parameters are related, and especially between damp ratio and natural frequency and damp frequency. It was also a bit confusing at first to interpret how adding zeros and poles affect the response, especially distinguishing between dominant and non-dominant poles. Visualizing the poles helped a lot in understanding these effects. So my key takeaway is that increasing damping makes the system more stable but slower, while adding zero increases the overshoot and makes the response more aggressive. And also, poles that are closer to the origin significantly affect the system response, while poles far to the left have minimal effect. Understanding poles is a very important in control system design. And that's all. Thank you.